Here we're going to talk about rate of increase and decrease. So rather than looking at the original function, we want to know when is it increasing most quickly or decreasing most quickly. Well, our increase and decrease is given by our derivative. So to find the maximum of our derivative, we're going to have to find our second derivative. So let's start by finding our first derivative. That's going to be our function that tells us our increase and decrease. Here, we've got two functions times each other, so we're going to use our product rule. So u is going to be equal to x to the 3. V is going to be log base e of x. So then our u dash is going to be 3x squared. And our v dash is going to be 1 over x. So now I can put my f dash of x together, and it's going to be u dash v, so 3 x squared ln x, and then u times v dash. Just clean that up a little bit. So here we got to cancel. All right, so that's given us our rate of increase and decrease. So to find the max, I'm going to want to do the second derivative, make that equal to 0. Now, again, this bit here, I'm going to have to do another product rule. But here, the end bit's just going to be 2x. So I'll just write that in now. So the product rule for this, u is going to be 3x squared. My v is ln x. So my u dash is going to equal 6x, and my v dash again is 1 over x. Just put that up a little bit. So my f dash of x, my second derivative, is going to be v dash x, so 6x ln x plus u v dash, and then don't forget the extra bit we had from before. Now cleaning this up, that becomes 3x, but we're actually going to have a 2x here as well. So I'll combine them together. Now, I want to make that 0. And that's a really awkward thing to do, make 0, because I've got the ln x and the x's, but as it turns out, it's not too bad. So if I minus my 5x off both sides, and I can see that if I make x equals 0, I've got one solution. But if it's not equal to 0, then I can divide by x. And in fact, I'm going to divide by 6x. Although, well, we'll come back to that. So minus 5 over 6 equals ln x. And then I have to work out what my x is going to be. I've got e to the minus 5 over 6 equals x. And so that's going to be where I have my other solution. Now, we've got an issue here because ln 0, remembering what ln is what power of e makes 0, and there is no power. So this one's not going to exist. But this one will. And if I actually wanted to find the rate, I want to sub that back into my the rate problem. But I think we'll just leave that for now.